Hi, today I'm going to start to talk about the position vector. Position vector is a vector that we use it to define a position of a given point in the 3D space. And later I will show that how it's useful that we are going to use it when we want to define the direction of any point on any line in our calculation. So the position vector for the position vector, consider that we have our x, y, and x, y, and z coordinate, and we have a point here at x, y, and z, and then we want to define that point. The position vector for that point goes from the origin to that point, and we call it r, and consider that the origin is sitting at 0, 0, and 0. So r, for that purpose, r is going to be xi plus yj plus zk, and its magnitude is going to be x squared plus y squared plus z squared. And the unit vector, if you remember, the unit vector is just the vector divided by its magnitude, which is what we are going to use it here to calculate the unit vector. And also we can remember the unit vector is cosine alpha I plus cosine beta j plus cosine gamma k. So also we can use it to find the angle of this vector between the x and y and z. So I'm going to try to show it. So the alpha is the angle between r and x, the beta is the angle between r and y, and the gamma is between and z, so that's the gamma. So we use it to define that angle, and this is basically gives us the direction of the line going from the origin toward that point. And it's very useful. Later on we'll show how we are going to use that to define the angle. This is basically when we have the single point and want to find the direction of that single point in 3D domain. But what if we have 2 points, point A and point B, and then we want to find the lengths of line connect point A to point B, or we want to find the direction of the vector goes from point A to point B. So let's look at that. So assume that we have that x, y, and z again, and this time we have point A. Assume we have point A here, and we have point B here, and assume that we want to find that direction. This time the position vector is this one, is going from point A to point B, from point A to B. So it's going to be that. If we know the position, the coordinate of A is xa, ya, and za, and the same for the B is the x at B, y at B, and z at B, then the position vector, like the one we have there, the position vector between A and B is xb minus xa I plus yb minus yaj plus zb minus zak, and its magnitude is just a square. Put the square, add them together, and take the square root. So xb minus xa squared plus yb minus ya squared plus zb minus za squared, the square root of that. So that's the position vector going from A to B. Similar to here, the unit vector going from A to B is r AB divided by its magnitude. And again, similarly as we had here, the AB is cosine alpha I plus cosine beta j plus cosine gamma k. And we'll look at that, what we had here, so we can use it to find the angle of line AB or vector AB, find its angle with the x, with the y, and with the z axis. And later on we'll show when we want to find the direction of the line or vector, the first method we have to use is just go ahead and find and look at the unit vector to find that angle. Now let's look at an example. If we have 2 points on the 3D dimension, how we are going to find the lengths of line that connect these 2 points. Also how to find the direction of the line that connect these 2 points. So let's try x, y, and z axis. And assume we have the point A that's located on the x-axis. Point A located here with the coordinate of 2, 0, and 0. And then we have point B located on the YZ plane with 0, 3, and 2. And then we want to find out the length of AB and the direction of AB. To do that, as I said, what we need to do is just first we need to go and find the position vector between A and B. To find the position vector between A and B, the position vector A and B is B minus A, B minus A, B minus A, I, J, and K. So 0 minus 2, I, plus 3 minus 0, J, plus 2 minus 0, K, which which we can simplify it. So AB is negative 2I plus 3J plus 2K. Its magnitude is just the square root of squaring all the component. It's going to be squared plus 3 squared plus 2 squared, which gives us 4.123. So this is the magnitude of that. So we have the position vector and its magnitude. So from there we can find the unit vector. But before that, this length, it just gives us the distance between A and B. So we know the distance between, that's the first one. We wanted to find out the distance between A and B. So we calculate position vector and its magnitude is the distance or the length between A and B. The next is that the direction of the A and B. What's the direction between A and B? And as I said that when we want to find the direction, the first thing we do, most of the time, the first thing we need to do is just go ahead and calculate the unit vector. So here the unit vector between A and B is RAB divided by its magnitude, the RAB, which is going to be negative 2 over 4, 1, 2, 3 I plus 3 over 4, 1, 2, 3 J plus 2 over 4, 1, 2, 3 K. So this is the unit vector that we calculated. And remember I said that also the unit vector, we can write it as cosine alpha I plus cosine beta j plus cosine gamma Okay, so if you compare these two together, you see that this part is cosine alpha, this part is cosine beta, and this part is cosine gamma. So I'm going to calculate cosine alpha, and the beta and gamma is the same. So we know that the cosine alpha is going to be 2 over 4, 1, 2, 3. Then alpha is cosine inverse of 2 over 4, 1, 2, 3, which is going to give us 119.2 degrees. The same, the cosine beta is 3 over 4, 1, 2, 3. Then the beta is 43.31, and the cosine gamma is 2 over 4, 1, 2, 3. Then the gamma is 60.98 degrees. So as I said, that when we want to look at the direction, we will go straight ahead and find the unit vector. So the alpha gives the angle of line AB with the x-axis, the beta gives the angle of line AB with the y-axis, and the gamma gives us the angle of between line AB and z-axis. So this is the magnitude of that line, and these are the direction of that line.